This is Access Reality. I'm Ali Kadili. We're joined today by Dr. Ryan Watkins. Dr. Watkins is a planetary scientist who focuses on moon exploration, and she's also on the advisory science board of Blue Origin's moon landing program. So thank you for coming, Dr. Watkins. I appreciate it.
Thanks for having me.
Awesome. So you are a lunar scientist. Would that be correct?
I am. That's correct. Yep.
It's a pretty cool title to have.
Yeah. I think so too. I enjoy it. I enjoy it a lot.
Yeah. So how many missions are currently active on or around the moon as we speak?
Mm-hmm. Yeah, at least 3. I'm trying to make sure I'm not forgetting any. So we have the primary one, at least that I think about every day, is the Lunar Reconnaissance Orbiter. So that is an orbiting mission, taking really high resolution data of the lunar surface from an array of instruments. So that one's been in orbit for about 10 years now. Then China has a lander and a rover on the far side right now, the Chang'e 4 mission. And then there's one that's not quite as well thought of, I guess, in the general community. It's called Artemis. This is separate from the upcoming human Artemis program. It's a pair of orbiters as well. I think it was originally designed maybe for heliophysics, and it's doing a lot of atmospheric type work at the moon and looking at dust and different things. So I don't think I'm forgetting any. So those are the 3 active ones at the moment.
So Russia currently doesn't have anything?
No, they do have plans to send some in the very near future, but they don't have anything at or around the moon at the moment.
Okay. Wasn't there an Indian mission also? Or?
Yeah, so the Indian one, I forget what, it was about this time last year maybe. They tried to land on the moon, and unfortunately it crashed, so it was not successful. They are planning to attempt another landing. Again, I think it's in the next year or so. I don't remember the exact timeline, but yeah, so there are a lot of countries that have their eyes on the moon right now and are actively planning missions, whether it be orbit or surface missions, yeah.
Of the 3 active missions that you mentioned, are they all kind of doing or looking at the same thing, or
no,
does one of them have a very different mission than the other?
Yeah, they're actually all pretty different. Again, the Lunar Reconnaissance Orbiter is taking orbital measurements, and we have a camera system that's taking really high resolution images. We have an instrument that's taking thermophysical measurements of the surface. We have another one that's taking topographic measurements, and then radar, and there's a couple other things. And then the Chinese mission, I am not familiar with their exact instrument suite off the top of my head, but again, all their measurements are being done from the surface, so they're taking what we call in situ measurements, so understanding things like the mineralogy of the surface, actually being there directly on the surface. So, things like the resolution is different, and then just the fact that you're actually on the ground as opposed to orbit. And then again, yeah, the Artemis one is more focused on things like kind of physics and dust and atmospheric type measurements. So yeah, so they're all doing different things.
I know the U.S. administration announced that NASA is going to have a mission or a spaceship orbiting the moon or something. Mm-hmm. Are there any concrete plans on anything else for the moon from NASA?
Mm-hmm. Yeah. So so the thing you're mentioning is the Gateway. So the idea with the Gateway is that it's kind of like, similar to the space station, not quite the same scale, but it will be, I don't want to say in orbit around the moon, because I think the idea right now is that it'll be at one of the Lagrange points. So it'll be essentially stationary in this area near the moon. And astronauts can come and go to the Gateway, and then from there they can either go down to the lunar surface and do, exploration and science, or they could possibly just go to the Gateway and operate rovers that are on the moon from the Gateway rather than from Earth. So that's kind of one of the ideas with the Gateway. The other plans from NASA, there's several things. The big one that everyone's really talking about right now is the Artemis program. So that's the program that's aiming to send humans back to the moon by 2024 is the current timeline. So that would be the first mission, and then the idea is that there will be a series of missions after that. The idea is that they'd really like to get what we call a sustainable presence on the moon through a series of robotic and human missions. So those are kind of the big, I guess, missions right now. There's also other, NASA actively has calls for mission competitions, essentially. There's different classes depending on the size and the cost of the mission. And there are often lunar missions that are proposed to these. There aren't any that are actively selected and being developed at the moment, but there are people working on proposals. There's also several CubeSats, which are really, small satellites that are going to go to the moon. and image things like the permanently shadowed regions, looking at volatiles. And I don't know exactly how many of those there are. I know there's several that are in the works that should be launching in the next couple of years. And then there's an array of instruments and things that people are sending on commercial landers and different things. So there's a lot going on with the moon right now. Yeah.
It just seems for decades after 1969, there's pretty much nothing, and all of a sudden now there's a renaissance of interest.
Yeah, for sure. Yeah, and this has kind of happened at least once before. So in the days of Apollo, everyone was real excited. Obviously, it was the first time we'd ever sent humans anywhere besides Earth. And so at the end of the Apollo program, no one really thought it would be this long before we were back on the surface of the moon. And we did have, under President Bush, the Constellation program was funded, and then we were actively working to try to get humans back to the moon. And unfortunately, that program was canceled. And so, beyond, some orbital missions here and there really hasn't been a large presence on the moon. But in recent years, there's really been, well, I guess it's not just recent years, but there's always been a push for Mars. Everyone wants to get to Mars, especially get humans to Mars. And that's a really great goal, but a lot of the community does believe that the moon is a great stepping stone to Mars. And that's not to say that the moon doesn't have scientific value in its own right, because it does. It's very highly interesting from a scientific perspective, but it's also very interesting from the perspective of let's go somewhere, learn how to live and work off of our own planet before we try to go somewhere like Mars, because you're going to be spending a lot more time, in space to get to Mars. And then when you're on the surface, you're going to be there for a while. So that's kind of one of the reasons for the big push. There was also, in the last few years, there had been the Google Lunar X Prize, which had been a competition for commercial companies to develop landers. And it was kind of a little race to see who could get to the moon first. And there were different cash prizes along the way. Unfortunately, no one actually ended up making it to the surface of the moon by the time that whole competition expired. But out of that grew a lot of these commercial companies that did start setting their sights on the moon. So yes, and there's a lot of partnerships right now between NASA and commercial companies. So at least from the U.S. perspective, that's why there's a lot of push to the moon. And again, like I said, it has a lot of value scientifically. So you've got a large lunar scientific community that's really pushing for getting back and answering questions from the surface. So yeah, lots of different angles that are kind of increasing this interest.
Yeah, as far as resources though on the moon surface, other than water and ice and helium-3, which could be used as a nuclear fuel, are you aware of any other valuable metals or other substances in the moon?
Yeah, I mean, like you said, the big ones that are talked about are the water, the hydrogen, or specifically the oxygen and the hydrogen. So I'm trying to think of other metals. There may be, I'm maybe less familiar with some of the work going on there, but in terms of resource utilization, one of the big things we're looking at is actually just taking the regolith or the soil on the moon and extracting these things like you mentioned, like the oxygen and the hydrogen. So there are processes that we can use to actually break down the minerals on the moon and extract these elements, this oxygen, hydrogen, and then we can create water. We can create rocket fuel because some of the primary components of that are just hydrogen and oxygen. So those are really the big ones that are talked about. And like you said, helium-3, again, not something I know a lot about, but it is of interest. There may be others that are of interest as well, other metals. I just know less about them. But yeah, the big ones obviously are oxygen and hydrogen.
Yeah. Now, as far as water, it's thought it's either mixed in with the soil or a layer underneath the soil. But I think there was some news lately that they discovered craters with large, massive amounts of frozen water. Is that true?
I don't know, just because I don't follow that super closely. Now, what I do know about kind of this idea of water ice on the moon, the big thing is that we don't really know exactly how much is there and kind of what form it's in. We have different data sets that have revealed that yes, there is some signature there, and it's likely mixed in with the regolith, but we don't really know. Could there be something like an ice sheet kind of buried? So there could be evidence, like you mentioned, for these craters that maybe have these larger masses of ice, especially in what we call the permanently shadowed regions, the areas that never see sunlight and thus remain incredibly cold and can retain those volatiles like water and hydrogen. So I don't know for sure if that's there, but I think that's really honestly one of the big questions we're trying to answer is just what is the nature and extent of water on the moon?
Yeah, speaking of water on the moon, is it true the US government actually sent nuclear rockets to explode on the moon, or did that happen, or
Um,
is that embellished, or
I feel like I have heard about this, and I don't know if it's true. It could be. We actually sent in, I want to say it was 2009, along with the Lunar Reconnaissance Orbiter that I mentioned before. We sent another spacecraft that they launched together. This was called LCROSS. And the whole idea was to crash this spacecraft into the moon. So we did that. We crashed it into an area near the South Pole, and then LRO flew through the kind of the plume, the debris plume that was generated during LCROSS's impact, and recorded the volatiles that were released from that. So that did happen for sure. In terms of the nuclear ones, I don't want to say yes or no, just because I'm not confident in the answer.
yeah. Now, would I be correct in saying that most of the discoveries on the origin of the moon and what it contains comes from analyzing rock samples? Is that right?
Yeah, that's correct. So a lot of the theories that are kind of still leading in our field right now came from, the Apollo samples. We like to refer to them as the gift that keeps giving. It's been 50 years, and a lot of these initial ideas and discoveries came from the initial analyses of these samples right after the Apollo missions. But even now, we're continuing to analyze them and learning new things. Yep.
Yep. Now, I'm assuming that when you analyze a sample of rock and you find some substances there,
Mm-hmm.
that some of it could be just native to the moon since its formation, so that could tell you about how the moon came to be,
Yep.
and some of
Mm-hmm.
it would be not native to the moon, but probably brought over by impacting asteroids. We don't know
Yep.
how far they'll go. How is there a way to tell these two things apart? Can you
Mm-hmm.
date them somehow, or?
Mm-hmm. Yeah, so this is going to get a little bit outside my area of expertise, just because I don't do a lot of sample work myself. But yeah, so a lot of people look at what we call the isotopes, elements that are in these rocks, and the isotopic signatures can tell us a lot about kind of where they came from, and that's one reason that the leading theory at the moment for the formation of the moon is from a giant impact with Earth, because we see some similar isotopic signatures in moon rocks and in rocks from Earth that indicate a potential common origin. So yeah, so if you were to analyze a rock and maybe it has some odd metallic signature or isotopic signature, then you could start to deduce, well, maybe this is from the impactor or from something else. And that's another way we can often find like a meteorite on Earth. There's a lot of other lines of evidence that suggest that it's a meteorite, but actually analyzing the minerals and the isotopes in there. So yeah, it's very similar. And again, it's a little bit outside my area of expertise, but kind of in a nutshell, yeah, that's one thing you can do with them.
Yeah, so that theory that you mentioned, so according to that theory, does it say that the moon is just a part of the Earth that's split off? Is that the bottom line?
Essentially, so at least again, on the level that I understand it, which is not a super in-depth level, if the idea is that there was a Mars-sized impactor that early in the Earth's history, this Mars-sized impactor hit the Earth, and a bunch of the material was then thrown off, and this material then kind of like sort of orbited the Earth and accreted, and eventually came back together and formed the moon. So in one sense, yes, it's kind of a chunk of Earth, but not like a big rock that was thrown off. It was kind of all this material that then kind of came together and formed what is now our moon. Yeah.
Okay. So moonquakes have been described, and as far as I know, it's not a myth; it's a real thing. So how is that possible when the moon itself is not geologically active?
Yeah. So the moonquakes on the moon, obviously, they're primarily driven by a couple of different things. There is some degree of seismic activity, but it's not the same as what we see on Earth. We don't have plate tectonics on the moon. The moon is essentially what we call dead in terms of at least geology. There's no active seismic activity or volcanism, but there are different things like tidal forces with the Earth that kind of push and pull on the moon, causing this strain, and that can cause a little bit of these shaking signatures. There's also, again, the moon kind of goes through these really intense, what we call diurnal cycles. So it's just the day-night cycle of the moon. And because there's no atmosphere, that means that the surface of the moon goes from very hot to very cold during these day-night cycles. And that can actually cause some, different contraction and things on the moon, and that can cause some of the seismic activity. And we see surface expressions of it on the moon, not necessarily like faults like you see on Earth. We see, different structures that are kind of pushing up on each other. And there's different levels of moonquakes. There's deep and there's shallow that are formed by various things. again, if you look at the Apollo seismic data, you sometimes see signatures just from impactors as well. So that's kind of what we're talking about when we mention moonquakes.
Yeah, so are moonquakes something that would be perceptible for a human being standing on the surface of the moon?
Yeah, that's a good question. I'm not super familiar with the strength of them. I want to say probably yes, but it's not going to be, on the scale of, like a really massive, devastating earthquake like we would feel here. And again, it's going to kind of depend on what type it is. If it's something generated by a meteorite impact or something, it's going to depend on the scale of that impact. The things that are happening more deep within the moon, I don't think you're going to feel on a super large scale. But that's, again, this is another reason we really need to get more seismic data. There's been a big push for more seismometers on the moon, so we can better understand these things, especially before we have a long-term human presence. Yeah, so again, still some questions to answer.
Okay, so this is going to sound like a question that a 4-year-old would ask, but what is the moon? What is the moon made of?
Yeah,
like the
so,
rock, the regolith, is it like just a different type of sand? Is it?
It's a few things. I mean, it kind of depends on, I guess, where you're looking on the moon as well. So for anybody who may not realize, the moon is what we call tidally locked with Earth. So we only see one side of the moon at any given point. So when you look up at the moon, like in the night, if you go outside right now, look at the moon, you're going to see kind of these dark areas and these bright areas. The dark areas are what we call mare. So these are old lava flows. So, go to Hawaii, you may see, these, what we call basalts. They're basaltic rocks. So they're volcanic rocks. So that's kind of what the dark areas are. They're a little bit higher in like iron and titanium and metals like that. But the primary crust of the moon, so early when it was first formed, it's made of a rock type we call an orthosite. So that's kind of the brighter areas that you look at. That's the primary crust of the moon. And these are kind of lower in the irons and the titaniums and different things. And there's other minerals and rocks on the moon, lots of olivine, pyroxenes, plagioclase, for anybody who speaks kind of geology, mineralogy terms. So yeah, but then when you mentioned the regolith, and essentially regolith is just kind of the crushed up rocks, and it can be made up of a mixture of things. There's a lot of other things in there, like what we call nanophase iron. There's glass particles. So yeah, again, there's a mixture of volcanic rocks and then just the primary crust of the moon. Yeah, now, it's geologically interesting. Yeah.
Yeah, is that completely alien, or are these all things that are also here on Earth?
Mm-hmm. Yeah, no, for the most part, these are all things that we see on Earth. There's a few differences here and there, like we don't see like iron 3+ on the moon. We don't see oxidized products, or we don't see any kind of rocks that would have been formed through processes involving water or aqueous alteration or anything. But yeah, for the most part, it's all things we see on Earth. I am aware of at least one mineral. There could be more, but at least one that was discovered on the moon that we, I don't really know if we've seen it on Earth or not, to be honest. But anytime you find a new mineral, usually it's named after someone. So it's actually called armalcolite. It stands for Armstrong, Aldrin, and Collins. So the Apollo 11 astronauts, they found it in some of the samples they brought back. So it was the first time that kind of mineral had been seen. But it's still, again, it's very similar to minerals we see on Earth. And we're always, we discover new minerals on Earth as well. So,
it wouldn't be abnormal for, let's say, if it had a common origin of the Earth, and then just because of its different exposure to the elements, lack of atmosphere, things that get oxidized in a different way. But it's that's pretty much all it is.
Nope, nothing super weird or
Okay. Now, do we understand anything about the geology of the moon in terms of its layers? What the core is made of?
We understand some. This, again, is kind of one of those other big questions we still would like to get more data to answer. So we know that the moon does have layers kind of similar to Earth. There's a really small, probably metallic core, possibly iron. It does have, a mantle and a crust. And again, we have this information from the Apollo missions because they did have seismometers, and we often get information about the internal structure of planets from things like seismic data or maybe radar. So it does have those layers. We don't 100% know what they're made of. Again, we have some ideas based on things like the seismic data, based on looking at craters that have brought up material from different depths and using our orbital data to try to figure out what those rock types are. But we don't know for sure what like the composition of the mantle, say, is. Really, like, we have good information on the depths of these things, again, from there was a mission a few years ago called Grail. It was a gravity mission that really told us a lot about the thickness of the crust. So So yeah, so one of the big questions is kind of getting back to the moon and getting samples from areas that may have excavated to depths that have brought up mantle materials and lower crust, because we don't know 100% for sure what those are made of. But again, like to answer your question, yeah, there are different layers.
Now, you mentioned the issue of the moon being tidally locked, so we only see one side of it, which, when I first thought of it, I thought that was really weird, but it's not that uncommon. There are other moons that do the same thing.
Possibly, yeah.
In the solar system. Do we know why that happens? Or because I don't think that's a natural, normal thing to happen unless there's other forces.
Yeah, and then, to be honest, I'm not really sure what may have caused that. I don't know if it's something with the size or just, how far out it is in the orbit. It's really not something I know the answer to. But like you said, I don't think it's the only instance of it. It's kind of one of just these weird phenomena that makes exploring our moon really interesting and unique, because if we want to see the other side, we got to go there.
Okay. Now, speaking of the other side, which is the dark side of the moon, is there any differences in the geology, topography, the soil makeup from the dark side to the near side?
Yeah, so there is a difference on the far side. It's not, okay. If you look at the far side, like if you just Google an image of the near side and far side of the moon, it's kind of what we call the dichotomy. So the far side has far less basaltic lava flows. Again, they're all, old and solidified now. But if you look, you really don't see as much of this resurfacing from volcanic activity. It is mostly just made up of the primary crust. The compositions of these things are not too drastically different. There is another phenomenon, we call it the prosolarium creep terrain. So if you look at something like, I'm trying to think, like thorium data or iron data, there's kind of this like big hot spot on the near side of the moon, kind of in conjunction with these Mare basaltic areas. There's a lot more radioactive kind of elements. Again, we call it creep. It's potassium, rare earth elements, and phosphorus. So areas that are really rich in these elements. And we don't see that on the far side of the moon. There are a couple areas of maybe like thorium hotspots, we call them, but not like what we see on the near side. So there are a couple of compositional differences, but kind of the big thing is the crust is a lot thicker on the far side, and there's a lot less volcanic activity, or at least these exposures that we've seen. Yeah.
Yeah, I was also thinking in terms of the dark side, theoretically, possibly, getting more asteroids. So would that make the composition of the topography a bit different?
Yeah, I guess I didn't answer your question about topography. So if you actually look at the far side again, it's a lot more cratered. And again, this is partly because it hasn't gone through any kind of volcanic resurfacing. And it could also be because it is the face that's facing away from Earth and may have been more heavily impacted. But that's, again, to say we don't really know that the near side, the side we see, could have also been just as equally impacted, but it went through all this volcanic resurfacing, which kind of resets a lot of those craters. So you may not see them when they've been covered and buried by lava flows. So it's really hard to say for sure if one side experienced more impacts than the other. But yeah, the far side does tend to be a lot rougher and have a lot more craters and things like that. So,
Is it true that all craters on the moon, regardless of their diameter, are pretty much like of comparable depth or similar depth? Is that true?
No. So they're actually different depths. There is, and again, I'm not a cratering person, but I think there is kind of like a relationship that's been maybe derived between the depth of a crater and its diameter. And I don't remember off the top of my head what that relationship is, but a lot of it depends on the thickness of the regolith where this impact is formed. So in an area like the Mare, where the crust is a lot thicker, you're more likely to hit, bedrock and create different depth craters. So yeah, so we do see different depths, and it's just highly dependent on the type of terrain that's being impacted and how thick of a layer of regolith or soil you got to get through before you actually puncture bedrock. That'll make a big difference. Yeah.
Okay. We talked about the moon having no atmosphere. Is that just a zero, like nothing, no atmosphere whatsoever?
That's a good question. And again, not something I really know a ton about. I do think there's maybe been some evidence for maybe like a transient atmosphere or some kind of very, very fine, essentially there's no atmosphere, but there may be some kind of, something there. And there are some theories as well that perhaps in the moon's past, with all the volcanic activity, when it was volcanically active, there may have been enough volatiles and like water and different things that were being outgassed during that period to create some form of atmosphere, but we don't really have anything significant at this point. Again, that's kind of one of the things that the Artemis mission is looking at is the atmospheric phenomena, but it's, again, it's not an area that I'm real well versed in.
I think they did find an ionosphere at least.
That might be what I'm thinking of then. Yeah, that does
Yeah.
sound familiar. Yeah.
And I'm just wondering how you get that without an atmosphere. It's just.
Yeah, there's, again, a lot of questions we don't really know. I mean, there's a lot of people also looking at like whether there ever used to be a global magnetic field on the moon or not, because right now there isn't. So.
Okay. All right. So let's go with no atmosphere whatsoever. So if there are challenges to setting up permanent bases on the moon, like obviously no pressurized atmosphere, no breathable air, extreme shifts in temperature between night and day, radiation, but you could protect against all of these with a proper habitat. But given that there's no atmosphere, would that still be unsafe to have a permanent lunar base or habitat, given that you have no protection from asteroids with no atmosphere?
Yeah. So that's kind of one of the big things that is being considered. And that's another question we're trying to answer is what is the current impact flux of the moon? Because we know it is still being hit. We have even data over the last 10 years from LRO of, we've taken images of the surface at different time periods and detected new impact craters. Now, you're not getting things on the scale, these like super huge, large impacts, on a regular basis, but there are very small impacts that over time are going to be of a concern, especially if you have a habitat that's being, bombarded. So that's one thing we need to measure is to figure out like, okay, what is the impact flux and how much of a problem is it? And then, there are people looking at different ways to protect something like a habitat. I've seen some people, theorize, like, well, let's like bury it in regolith or bury it in the soil because most of the impacts are small enough that you got a nice thick layer there. It's not going to be a problem. Another thing that some people are considering there are these lava tubes or lava pits on the moon. So we've imaged these basically holes in the ground on the moon that lead down into underground lava tubes. We see similar things on Earth. And that would actually be a really ideal place to build a habitat because you can get there, you get underground, now you're shielded from the radiation, from the extreme temperature changes, and from the meteorite impacts. So that is something that's being thought of. It's obviously technologically a little more complex because you got to get everything down in there and build it. But yeah, that is something that's being considered to better protect your habitats and your people on the moon.
Okay. But right now you're saying we don't know like the rate of asteroid impacts. Like if you had a base, what the exposure would be, how many asteroids would?
I think there's some estimates of the rate, but I don't know that we know for sure based on the different sizes of impacts and things. But there are people that are actively looking at that, and I think they do have some good estimates that would probably be sufficient for sending humans in the next few years and starting to build a base. But it is something you're going to want to actively think about. As well as just, how much damage could this potentially cause?
All right. And can you tell us what magnetic swirls are and why they're there?
Yeah, well, I can't tell you why they're there because that's something we're still trying to figure out. But yeah, so on the moon, there are these features we call swirls. They're exactly what they sound like. They look like these just really bright swirls on the surface of the moon. They're actually really beautiful to look at. They have no association with topography. From what we can tell based on our orbital data, they don't have any differences in composition to the surrounding terrains. They're just these features that consist of really bright areas, and sometimes they have dark bands in between. And kind of the leading theory for why they're there is that there are we know there are local magnetic anomalies, and often these swirls are associated with those. So when you look at the moon again, you'll see a lot of the surface is pretty dark. So we don't have weathering in terms of like, wind and rain on the moon, but we do have weathering from the solar wind. So the solar wind interacts with the surface of the moon. It creates these tiny little iron particles, and that causes the surface to look darker over time. This takes, a long periods of time to really darken. So if you look at the moon and you see a crater that has these really bright rays coming off of it, that means that crater is young. It hasn't been exposed to the solar wind long enough to really have those rays darkened. So one of the theories with these swirls is that they have these magnetic fields that are protecting them from the solar wind, and they're not being weathered and they're not being darkened over time like the rest of the surface. So that's kind of the leading theory right now for what's causing these swirls is these local magnetic fields. There's a couple other theories. There's some people who've hypothesized that they're formed by cometary impacts that kind of jumbled up the surface. There's a couple other theories with the types of particles that are there, and magnetic separation of particles that's creating these really bright features. But really the leading one is these magnetic anomalies.
Yeah. So for you personally, what are the top 3 questions you'd like answered that are left unanswered?
Ooh. Yeah. So 3. So there's one question that it's a little more geared towards the side of just exploration that I'm really interested in. I've been working on this since my career began, is understanding how rocket exhaust interacts with the lunar surface. And this may seem, kind of small in the grand scheme of the moon, but if you're looking forward to, all of these different countries going to the moon and having a long-term human presence, it does become very important. So when a rocket lands on the moon, it blows dust, and obviously it's not that hard to think about, but we don't know exactly what it does to the surface. We have some ideas. We think it might smooth the surface. There's, obviously particles that are blown away. Maybe there's particles that are redistributed. But this is very important for a couple of reasons. One, if you're going to send a spacecraft to the moon, and you want what we call pristine sample, you want a sample that's not been altered by your spacecraft in any way, how far away do you need to go before you're in an area that's not been affected by rocket exhaust? So that's one reason it's really important. The other is because the speeds at which these particles are blown away from the spacecraft are incredibly high, so high that some of these particles actually reach the escape velocity of the moon. So if we're going to start, maybe build a habitat and start landing multiple times in the same area, suddenly we could be sandblasting our habitat or our rovers or any of our hardware that are nearby. So this is a question we really need to understand a lot more about in terms of the physics that happens and the interactions with the soil. So that's one big thing that I'm working on.
So do you foresee regulations then in the future on where craft can land and not land?
Yeah, we actually already have, we have some, I'm using kind of air quotes here, because nobody owns the moon. So it's really hard to place regulations on, like, you can't really tell another country what you can and can't do because no one owns it. But actually there was several years ago, I was kind of mildly part of the effort that the US or NASA did actually write up some guidelines. So this was, again, going back to the Google Lunar X Prize, because one of the extra cash prizes for the teams was roving up to an Apollo site and taking pictures. But there was some concern about protecting these historic sites, because if you land right next to it, again, like I just said, what if you sandblast it and damage something historic that's obviously of just value to us? So we actually established guidelines for, you need to be at least this far away when you land. Okay, roving is different. You can drive up there. It's not as big of a deal. I mean, you could possibly, roll over some astronaut tracks that are, again, just of historic significance. But we did set up these guidelines. All of the teams said they were going to abide by them. Again, no one ever ended up making it to the moon. But yeah, so this is kind of something that people are working on, is just like, yeah, you got to have guidelines. You got to, maybe we got to find a way to build a landing pad while we're on the moon. There's a lot of work being done here, but just still a lot we don't know. And I think within the next few years, with, the increased cadence of missions, we'll have a lot more data to help answer these questions. Yeah, so that's kind of one of the big things that I'm really interested in. And again, I'm going to answer all of these from my own personal interest rather than, just because we have a list of priority questions in the lunar science community, but I'm going to tell you what my favorites are. Another is, it's kind of hard to condense this, but I'm really interested in volcanics on the moon. And there's a couple different directions I could go there. But one of the ones I've spent the longest time thinking about is what we call silicic volcanism. So when you look at the moon, you see these dark areas, old lava flows. These are basaltic. And like I said, they're higher in iron, titanium, and those types of things. But there's these more rare areas of volcanism on the moon that are more silicic in nature. So things like maybe granites. So, maybe you have a granite countertop in your house. These rock types we don't have many of from the Apollo collection, but we do have orbital data that indicates that there are a few areas on the moon that have these types of rocks. But there's a lot of questions that kind of still are centered around this, on like, how did they form? Like, what does this mean about the thermal history of the moon, and different things, and exactly what rock types are there, like how much silica content is there. And we just don't know, and we've got to get there and get samples to really find out. So again, a lot of those questions kind of tied just back into the actual evolution and history of the moon. So also very interested in that. The third one, again, this is something I've been working on recently, is understanding how long it takes to produce regolith, specifically from boulders. So like we mentioned before, the surface is constantly being bombarded by micrometeorite impacts. And so when you have something like a boulder on the surface of the moon that is constantly being impacted by these tiny little particles, over time, that boulder is going to break down and it's going to become part of the regolith. So this is something we're interested in from, again, a scientific perspective of just like how long does it take boulders to break down on the moon, but also from an exploration perspective, because if you're planning to land on the surface, you don't want to go land in a boulder field because that's just not going to be good for your spacecraft. And most boulders on the moon, with a few exceptions, most are around really young, fresh impact craters. Because again, you hit that bedrock, you produce a bunch of rock. So I've actually been looking at the correlations between the boulders on the moon and craters and what we know about their ages. And then using that data to try to figure out, well, how long does it take for these boulders to start disappearing? And once you have like a good database built up, then you can start predicting, all right, well, how far out from a crater might we find boulders? What age does a crater need to be before we even have to worry about there being a significant presence of boulders? And so there's a lot of good exploration and scientific questions kind of tied into that. So again, very much answered from my personal interest. There are a lot more very interesting science questions for the moon beyond just those.
Yeah. Do you, I mean, I know you're focused on our moon exclusively, but have you looked at, studied, come across information on other moons in the solar system?
I really have not. I mean, you know, I'll read things here or there. I'm really interested in some of the moons that have these, you know, like plumes and jets, and they have like water and things. I think those are really interesting. I know very little about them other than that they seem really, really cool. There are, you know, Mars has 2 moons. There's a lot of theories about whether they're captured asteroids or formed maybe from Mars itself. So those, you know, are of interest. I'd say most of the time when I think about doing any kind of comparative studies with the moon, you tend to lean more towards looking at other asteroids rather than other moons, because there's just no other moon that's really that similar to ours. But that being said, I think the other moons are all really fascinating. You know, there's, you know, Io that's got all of these, you know, active volcanics, and then there's the ones that may have water. And but again, I couldn't like sit here and give you a good science case on any of them. I just know that they're all very, very interesting in their own right.
Yeah. Is there anything that stands out as being super special about our moon, other than the obvious, the fact that it's close to us, it is the size that it is, and everything else?
Yeah. I mean, I think again, like you said, it's a lot of it is the obvious. It is our nearest neighbor, so that makes it super interesting, super easy to study. There is a theory that like, did it come from our planet? I think one of the things that really makes the moon super interesting is just the fact that understanding its history can really tell us a lot about Earth's history in terms of, you know, formation and impacts and all of these different things. So I really think that's kind of the key thing that makes our moon interesting. It's just that it tells us a lot more about our own planet, which obviously is the one that we all love the most. So.
Yeah. And we always tend to think about the impact the moon has on Earth, the tidal waves, you know, etc. The moon would be a very different place if it wasn't in our orbit. Yeah. So what are the biggest things you think that would be different if it was just, you know, a rogue moon or planet?
Yeah. Ooh, that's a good, I mean, like you said, I mean, I think that one of the obvious ones is, you know, like you said, the tides. We wouldn't have those anymore. I'm trying to think of other ways that the moon, yeah, I mean, this is just, we wouldn't have eclipses anymore, and those are really interesting. So, other than that, that's a hard question to answer. I think, let's say that the moon was just kind of a rogue thing out there. I think it would still be interesting, but I think it maybe would be a lot less interesting to us. We'd still want to understand things like what is it made of, but you lose all those connections of the Earth-Moon relationship that really, drive what's so interesting about it.
And how would the moon itself be different if it wasn't around us?
Yeah, well, on one hand, it wouldn't be tidally locked. So perhaps, and again, this goes back to not really understanding exactly this dichotomy on the 2 sides of the moon and why the crustal thickness is different and the volcanism is different. But let's say that's somehow tied to its relationship with Earth. I mean, the surface of the moon as a whole could then potentially look very, very different in terms of, you know, the volcanic activity and the impacts. I think that would be one of the really big ones that would be a lot different about it.
And you think it would start spinning around itself?
Maybe, yeah. I mean, again, without having a lot of understanding of how this tidally locked thing happened, like, it could just very well be spinning and be a whole lot different than it is now. Yeah.
All right. Now, you're on the Science Advisory Board for Blue Origin, right?
Yes.
And your role, how active is it? Are you just literally an advisor to their teams of engineers who are doing projects, or are you do you take the lead on some things, or?
No, it is very much more of an advisory role. So it's for their Blue Moon lander project specifically, which they unveiled about this time last year.
So what
so
is
they
that? Is
are
that a rover? Is that a spaceship, or what?
Yeah, it's a stationary lander. So the idea is that they'll be able to, it's pretty big. Just Google some nice pictures and you'll see the size of it. But yeah, so the idea is that it's a lander, and different companies can, and including NASA, can pay for payload space. So they're kind of serving as a way to get payloads to the moon, and they can carry things like rovers or just different scientific instruments. But yeah, so as part of the advisory board, we kind of advise them, again, like you said, their engineering teams on a lot of different things, including like what kind of payloads should they consider, what kind of capabilities do they need to support these payloads in terms of thermal power, all that kind of stuff. Like what do scientists want, and then things like landing site selection. What are good areas to focus on? Again, I do some of the consulting with those rocket exhaust effects and things they need to look out for there. So yeah, so we really come at it from like a lot of different approaches in terms of, just telling them from a scientific perspective, things that they may want to consider, think about, as well as some programmatic things. There's some people on the board that have a lot of experience just working programmatics with NASA and can kind of bring some of that to the table as well. So.
Yeah, but it's not for humans, right? It's not
No,
it's not designed to carry humans.
No, the Blue Moon lander that they unveiled last year, that one's not large enough for humans, yeah.
Okay. And as far as you're concerned, Blue Origin in general, is it mainly focused on this, like on getting to the moon? As opposed to,
I mean, that is,
SpaceX, like they go to Mars and there's other, but
yeah, right now, Blue Moon, Blue Origin, as far as I know, again, without being, an official employee in there, as far as I know, yeah, their sites are on the moon. Now, Jeff Bezos does have a grand vision for, just this long-term human presence in space, whether that be on the moon or in some kind of, habitat in space, like, a space station or something. He does have this grand vision for just expanding humanity into space. And if you go back and look at, it was actually at the Blue Moon unveiling, he kind of went through his whole long vision of what he sees in terms of the future of space exploration. And but he didn't really mention like any other specific planets like Mars or another moon or an asteroid or anything. It was just kind of humans in space and really kind of getting our presence there.
Yeah. And how far away is that Blue Moon lander project from actually being realized?
Just a few years. I don't remember, I'm trying to remember, maybe 2023, 24. So there's some commercial companies that are looking a little more near term, like in the next year or two. Blue Moon is, a couple of years, maybe beyond that, just because it's a much larger scale lander than most. It takes a little more development, and they're also working on their, I always get them mixed up, New Glenn rocket. That's their more heavy lift vehicle that can actually get them to the moon, because they have New Shepard right now that's more suborbital. So a lot of it's tied in with the timeline of getting that rocket developed and tested.
Yeah. All right. And finally, I just wanted to ask you what your prediction is of what this is all going to culminate in, like 5 or 10 years from now, in terms of what will the moon look like?
Okay, yeah. So I think the moon is definitely not going to lose its place as a scientifically valuable target. So from the scientific community, at least, you're going to continue to have this push for, let's get back, let's get some samples, let's get some data, let's get some rovers. But really with this huge kind of influx in the last few years of new commercial companies and international interest, I really think in, let's say, the next decade, we're going to see a lot of missions to the moon. And it's not going to be just the US. It's going to be a huge international effort. I do want to see, humans back on the moon. I think, the current timeline is 2024. Whether it happens by then or in a couple years after that, I do think we're going to see it happen in the, next 5 to 10 years. Ideally, I would like to see, kind of this sustained presence, this regular cadence of sending humans to the moon, sending rovers to the moon, even if they kind of switch off. In terms of whether we'll see humans living on the moon for long periods of time, that one I'm not sure about, because you have to define what is a long period of time. Is it a few months? Okay, that might happen. Is it a few years? I don't know if that's going to happen in the near future, but again, it's something to aspire to. But I do think we're really just going to see a lot of surface missions and orbital missions from different countries. I do think at some point we're going to see another country send humans to the moon, whether it be China or Russia. I don't know who will do it first. I do hope we are the next ones back there, just because I want to see us kind of leading the effort back to the moon. But yeah, I just think it's going to be a huge influx of new data and new surface missions, and I think it's really just going to be an exciting time to be looking at the moon. And again, gearing towards Mars. I really think that's kind of an end goal that everyone has in mind, without taking anything away from the moon itself, because it is valuable. But I do think we're going to see a lot of missions to the moon, and then we're going to see a lot of progress being made to going forward to Mars.
I think if the Mars thing happened, you'd be focused a lot on studying the 2 moons of Mars. So you're just a moon lady, so it's going to be all
I love the moon. Yeah, no, and there are other things I'm interested in, but the moon is always going to hold, a very special place in my heart. I'm not opposed to, doing some work on any of these other moons, or even like Mercury or some asteroids. But yeah, the moon will always probably be my number one. Mm-hmm.
All right. I believe you, because I think your necklace has the moon on it, doesn't it?
Yes, it does.
That's dedication. Yeah.
Thanks.
Awesome. Great. Well, thank you, Dr. Watkins, very much for your time.
Oh, thank you. Thank you for having me. I really enjoyed it.